All right, we're going to be working through the 8.2 notes, and essentially we're going to be using square roots to solve quadratics. So anything that's been that has like an x squared or usually you're going to see x, but any variable to the second power is a quadratic, and so we're going to be working particularly with like x's though. As our domain. So when working with these, essentially we're following the rules to solve an equation, and you've learned the rules in solving equations when we talk about, like, I'm just going to do a little example here. For example, like I'll do a kind of a complicated one. Let's do 2 times 3x plus 4 plus 7 equals 21. Okay? And there's a few different ways that we could approach this. We could actually clear, and we're going to work on doing this later, we could clear this 7 and this 2 by subtracting the 7 to both sides first. And then we would have 2 times 3x plus 4 equals, this would give us 14. And then what we could do is divide 2 to both sides. And then we get 3x plus 4 equals 7. And then I would subtract 4 from both sides so that 3x equals 3. And then I divide 3 to find that x equals 1. Okay, so like that's just solving an equation. So that's one way to do it. The way that we've really been working with has been, and we're going to use more this way than anything, but you could also have distributed, right, and gotten 6x plus 4, and then plus 7 equals 21, and then we would put 4 and 7 together to get 11, so 6x plus 11 equals 21. And then I would subtract, oh, no, it's not 4. Man, nightmare. 2x times, 2 times 4 is 8, right? So 8 plus 4, or 8 plus 7 is going to give us 15. Just trying to do this fast, and I shouldn't have. I subtract 15 to both sides, and 6x equals 6, and then we divide by 6. And x equals 1. So we've learned like these steps to solving, right? And it's called doing the inverse operation. So when I needed to get rid of this 15, I do the inverse operation. So if it's positive, I can subtract 15 to both sides, and it undoes adding 15. Everything's in relation to the x. So in relation to the x, the 15 is adding. So if I subtract it, then we get rid of it. In relation to the x, this 6 is multiplying, and the inverse operation, or the opposite of multiplying, is dividing. So solving equations is all about doing the opposite operation, or the inverse operation, to undo whatever the value is doing to x. So we're going to just talk for a moment. Think about the inverse operation of multiplication is division. The inverse operation of addition is subtraction. And those are kind of the main ones that we use when solving when solving equations. Today we are going to talk about how the inverse of something to the second power, so a power, so like let's say the inverse of x squared, the inverse of that is to take the square root. So a square root undoes a second power. So the same way that multiplying and dividing will undo each other, adding and subtracting undo each other, a second power and a square root will undo each other. Okay, so we're going to use that information to kind of solve these. So I'm just going to jump into some example problems here, and you'll get to see how this works. So we have x squared equals 64. So I've given us some very simple ones early on. We take the square root of both sides. So think about a square root undoes a squared, so now it's just x by itself. Okay? But when we're solving and we take the square root, we're actually going to get two answers because there are two values that x could be. X could be positive 8. X could also be negative 8. Okay? And I got that from taking the square root of 64. So x is equal to plus or minus 8. And if we plug that back in, you would see if I plug in, so we had x squared equals 64. If I plug in 8 for x, eight times 8 does equal 64. If I plug in a negative 8, negative 8 times negative 8 still makes positive 64. So that's why it could be the positive or the negative value, because when we have a squared, the number stays the same, but the positive or negative value could be squared to get us to our answer. So there's just two answers with these, okay? So you'll get comfortable with that positive or negative. So when we see something like this, x squared equals 25, we're going to take the square root of both sides because a square root undoes a squared. And that gives us x by itself equals, and then we're going to take the square root of 25, which is 5, and it could be the positive or negative value of 5. So we're going to say plus or minus 5. Okay, the other way you may end up writing this is 5 or negative 5. And that would be for like your delta math. Okay, let's look at another one. So far, hopefully this is just a very simple concept. These can't cancel each other out. Because x is being squared, what's the opposite of squaring something? It's taking the square root. And that's going to give us positive or negative 3. The square root of 9 is 3. Okay, so that's when our variable is being squared. We can also have this where a whole quantity is being squared. So down here we have this whole quantity of x plus 2 squared. And the whole quantity is by itself. So I always want to make sure that this is like by itself, that there's nothing sitting outside of it. Once that's the case, we're going to take the square root here because that's going to undo this second power. What you don't want to do is expand this out to be x plus 2 times x plus 2. That is what this means. But you don't, like, solving using square roots avoids a lot of extra work. You would multiply this out and create a quadratic and then have all kinds of work to do. So when you're told to solve using square roots, I mean, use the square roots. Don't do anything funny. Okay? So square root undoes a squared, which leaves us with x plus 2, which equals positive or negative 8. Okay, and there's a couple different ways that we can approach this. We still need to get x by itself. So x still isn't by itself. We need to move this 2 now. I can get to this 2 because I got rid of my parentheses. I couldn't subtract 2 here because there was too much other stuff going on. I wasn't allowed to get to it. So now I'm going to subtract 2 to both sides. So x equals, well, it's really positive 8 minus 2. And x equals a negative 8 minus 2. So when I'm subtracting 2, on my first one, 8 minus 2 is 6. And on my second one, negative 8 minus 2 is negative 10. So these are actually the two values that x could be. Let's do another practice one here. Okay. In fact, I would encourage you to stop the video, pause it real quick, try this problem on your own, and then compare it to what I did. All right, so in order to get rid of that squared, we're going to take the square root. Then we'll have x minus 3 equals plus positive or negative 5. And then I'm going to add 3 to both sides because I need to get my x by itself. And you can do the mental math here if you want. Oop, I wasn't paying attention. You can do the mental math here if you want. You can say, okay, if it was a positive 3 plus 5, that's going to make 8. And if we had a positive 3 minus 5, that's going to make negative 2. So those are our 2 answers. If you want to write it out separate like we did on the last one, you're more than welcome to do that. In fact, it's going to come in helpful here because, okay, I need to take the square root on both sides. And that's going to leave me with 2x minus 7 equals positive or negative 11. So now that I have this positive or negative thing, I'm best off to split and have one problem. I'll do a red problem here that equals positive 11, and I'll do a blue problem over here that uses my negative 11. It's kind of similar to like the splitting and stuff we had to do with absolute values. So that's going to make 18. And then I divide 2. And my first value, x could equal 9. That's the first value that x could be. My second one, okay, that's going to give me 2x equals negative 4. And then I'm dividing 2 to both sides. And x equals negative 2. So these are the 2 values that if I were to plug them in, they would make x true in our original equation. So we do some quick mental math here. If this was a 2, or if this was a 9, 2 times 9 is 18, minus 7 is 11, and then 11 to the second power is 121. Over here, if I plug in a negative 2, I'm saying 2 times negative 2, which would make negative 4, minus 7 is negative 11, and negative 11 to the second power is 121. Okay? All right, and then sometimes you're going to get things that, like the first 6 examples, reduced really clean and were used perfect squares. Some of these, okay, I need to get x squared. I need to get rid of that squared, so I'm going to take the square root. And some of these, like this one, you're not able to take the square root of 29, so you just leave it as square root 29. It's a prime number. You would want to break it down. I went through Delta Math like a ton of problems just to check to see what kind of problems you would get. And you didn't really have any where you had to try and break down the radical. But this would be our answer here. Positive or negative square root 29. Square root 29 is like a value. We're just not going to calculate it. If you were to hit, 29 and then the square root button in your calculator, you would get a number. But for this purpose, we typically leave it just as positive or negative square root 29. Okay. So same deal here. I've got to get rid of this squared, so I'm going to take the square root of both sides. And I get x minus 3 equals plus or minus square root 6. So if you notice the square root 6, there is no square root of 6, right? It's no clean number. And then I still need to get x by itself, so I'm going to add 3 to both sides. And for this one, x equals 3 plus or minus square root 6. This is our solution. There's 2 values, but we're not going to go through and calculate what 3 plus whatever decimal this is, and then 3 minus whatever decimal this is. We're just going to leave it like this, okay? And then finally, take the square root here and the square root here. And that's going to leave me with 2x plus 3, which is great, equals, I can't take the square root of 51. 51 is a prime number. So we're just going to have plus or minus, or it's not a prime number, but it's, I don't think there's anything hidden inside of it. So 51. And then we are subtracting 3. So 2x equals negative 3 plus or minus square root 51. And then we're dividing 2. So x equals negative 3 plus or minus square root 51 over 2. Again, 51 is an actual, square root 51 is an actual value. We're just not calculating it. We're just leaving it how it is. All right. So let's talk about kind of the second part. So this is kind of the main math component that's new that we just looked at. Okay, so it's taking the square root of both sides. You get, when you do that, you get a positive and negative value, and you may have to solve out to get your final answer once you've done that. The last 6 kind of examples here are to show you the first part that you may need to do in order to get to this part. So in order to get to this math, you may need to isolate the squares first. And in order to take the square root of an equation, so think about the order that we solve equations. We look for whatever's adding or subtracting first, we move that, and then we take whatever is multiplying or dividing and we move that, right? So there's our order to a 2-step equation. For these, the order is we have to get the square by itself. So the squared term or quantity. So whether that is just a single value, a single variable, or it's the parentheses itself, it's the quantity, we have to make sure that it's alone first. So we're going to have to isolate it. We're going to have to move stuff away from our squared to get it alone first. And then once it's alone, then we can take the square root of both sides and solve. So then we can start doing what we've learned up here. So for example, this second power is only attached to my x. And eventually we're going to need to take the square root to get rid of this second power. But we're not going to be able to take the square root until I move this 4 and I move this 2. So I'm going to follow my order of operations for solving an equation, which means I'm going to subtract 4 from both sides first. I'll be left with 2x squared equals 76 minus 4 should give me 72. And then I can divide to get rid of this blue 2 that we had, right? So I'm going to divide 2 to both sides. And that's going to leave me with x squared equals 36. And now I'm allowed to take care of this squared by taking the square root because it's by itself. And so now we find that x is equal to positive or negative 6. It's the square root of 36. Okay, so again, this squared is attached to this x. I need to move the 16 and the negative 3. The negative 3 is multiplying. The 16 is adding. So I need to get rid of whatever's adding or subtracting first. So I'm going to get rid of this 16 first by subtracting it. And that's going to cancel out there. So I have negative 3 times x squared still equals, that's going to give us a negative 3 on this side. Now I'm dividing because I have negative 3 times x squared. So I'm going to divide. And x squared equals positive 1. Now I can take the square root of both sides, get those to cancel out to find that x is equal to positive or negative 1, because the square root of 1 is 1. All right, I've just got tons of example problems just for you to see, and these were pretty much all pulled from Delta Math. So again, here I need x squared by itself. Right now it has a 19 that is trying to add and subtract to it, and it has a negative 1 that's attached to it that I'm also going to need to get rid of. So I'm going to start by subtracting this 19, get that out of the way. It's going to make negative 6. Okay, now I need to get rid of this negative that's multiplying with x squared. So I'm going to divide a negative 1 because that's going to get those to cancel out to become positive x. What I do to one side, I have to do to the other. So that's going to make that a negative 1. It's going to make it now a positive 6. And now I can solve by taking the square root. So those cancel out. X is by itself. I can't take the square root of 6. Anytime we're taking the square root with an equal sign, we're going to use a positive or negative. So that would be my solution there. All right, let's do some like more complicated ones just so you can see. These ones are just with the quantities. So for our first one, I need to get this squared is affecting this entire quantity. So I need to get this whole thing by itself before I can take the square root on both sides. So for this one, I need to move this 8 first. So I'm getting rid of that 8. On the other side, it's going to make 16 here. And then I'm still left with my quantity of x plus 10 squared. Okay? Now that I have my quantity by itself, now I can take the square root to undo that, which is going to leave me with x plus 10 equals positive or negative 4. Okay, now that I have that, I'm going to go ahead and split this because I'm going to have an x plus 10 equals positive 4 and an x plus 10 equals negative 4. And we can solve each of these. So it's like it's solving inside of solving inside of solving. So our first value for x could be a negative 6. Our second value for x could be a negative 14. So sometimes we're going to have a two-step equation before we can get to taking the squared. This one's even funnier because if we look, initially we're thinking, oh, we got to get this whole thing by itself. But look, this is really the only thing the 2 is attached to. So I'm going to do lots of inverse operations to move stuff around. But essentially, I need to get that x to the second power by itself. So I'm going to get rid of this 5 first because this one's adding and subtracting. I can't touch this 9 because it's inside the parentheses in the group. So I'm going to get rid of this 5 by adding 5 to both sides. That's going to make 0. So now I have 5 times x to the second power minus 9. And I can divide this 5 now. I could also have distributed it in, but kind of would have created extra work. So I'm just going to keep consistent with that. Once I've gotten down to just my parentheses here, I can leave this. That's fine. Okay, so I'm going to put a 0 here. And I'm adding 9 to both sides now. Remember, my whole goal is to get this x to the second power by itself. So I had to move a whole lot of stuff. Okay, now that x to the second power is by itself, now I'm allowed to take the square root of both sides. And I'm going to be left with x is equal to positive or negative. The square root of 9 is 3. We can take that. So it's just, this is like next level applying what you know about solving equations, okay? For this one, we're going to take the square root of this whole thing. That's how we're going to have to solve this one because the square root is attached to this whole group. So I'm going to need to move the 15. I'm going to need to move the 4, and then I'll be allowed to take the square root. So I'm going to add 15 to both sides, and that's going to make 40 on this side. I still have 4 times the quantity x minus 9 squared. Now I can get rid of this 4. I could not distribute this in because this squared isn't allowing me to do that. That would be out of order. Because remember, order of operations, if I wanted to distribute to multiply, I have to make sure that I've done parentheses and then exponents before I do multiplication. And so I would have to work this out first. So I wouldn't bother with even thinking about multiplying it. Just divide this stuff out to get rid of it. Now that that's by itself, I can take the square root of both sides. That's going to undo the squared, so I get x minus 9 equals plus or minus square root 10. 10 is not a perfect square. And then we're going to add 9 to both sides. So if you get a perfect square, if you get like a whole number over here, I would say split it and solve for each. If you get a variable, then, or if you get a radical, then I would say you're good to just, this is going to give us 9 plus or minus square root 10. Okay, hopefully this made sense. I would say go back, even look at a blank sheet of this and try a few on your own just to see, and then come back and compare if you'd like to, okay?